G'day comrade subscribers. So I thought since we've got this out, we'd have a quick look at the Parus VI-201 from Sevastopol in Crimea. So this one is, was it month? October 1993, number 595 or number 595, I'm not sure. So ZX Spectrum clone, of course. So I've pulled it apart, given it a nice clean. So it was a little bit dusty and had some marks on it, but it's all looking pretty, well, much better now. So when I tried it originally, I've only done one video. It wasn't working, so I didn't get far. This is the keyboard that I've unscrewed. It's actually, it's a little squeaky. But I think we can fix that. It's actually got it's actually a rubber dome keyboard, so I can actually pull it apart. And we'll give this a good wash as well. Interesting section here for maybe a speaker, perhaps. And drilled some holes through. It's actually just got a piezo on here. So let's pull the keyboard apart first. Okay, some flatted slot screws. I'll undo these and be back. Okay, all the screws are undone. So this is actually quite a nice design. It's one of the very few that have got a detachable keyboard, which is nice. It just makes it so much easier to work on. So let's take that off. Okay, it's quite a oh, someone's signature. It is actually, feels like quite a thick board. Yeah, so looks like I don't want to peel it off if it's, I don't know if it's just stuck on because of age. Although it does look like there might be, I'm not going to force it. It looks like it might be kind of, I don't know, sealed around the edges maybe, but it's not coming off easy, so I'm not going to force it, but I can give that a bit of a clean. So that's that, and that's the keyboard. Oh, got a little broken one there. I'll have to fix that. But I'm assuming, okay, that's the C button. I'm assuming the keycap comes off and then the rest of it goes through. Is there any way to test that? Because it is quite a nice keyboard. So apart from that bit being broken, there it is. Alright, so I'll try and fix that up. Let's see, is there some way to... I guess I don't need to pull these apart to give this a wash. You can see there's quite a bit of dust. Don't worry, I'm not going to go on about speculate about where the dust may have come from. But that C would probably be good to come out, so I could fix it. But yeah, otherwise it's a pretty, apart from the squeakiness, it's a decent feeling keyboard. So there we go. We'll put that aside to be looked at later. But here's the main thing we've had a look, slightly looked at before. Let's have a closer look. It's quite a nice design, this one. As you can see, we've got those fancy, expensive decoupling capacitors which have somehow managed to survive, not being chopped off and sold for a few rubles. Got some resistors, a whole bunch of transistors, I guess. Now these ones here with their numbering on them, they are that kind of programmed logic like PALs or GALs or something like that. So we've got 101, 102, we've got 103, 104, I think I did see a 105 somewhere. So that's obviously, that's the speaker there. Lots of Space Invader capacitors. I guess this, yeah, I'm not sure. So it does actually have a RF or UHF modulator output there. So I guess we could get composite CCAM output out of this thing as well if the RGB isn't working. Got a that's the reset button up there. But oh, it's an unusual resistor for a well, I think this is post-Soviet machine. Actually, yeah, some of those you see the mixture. You've got the mixture. You got the banded ones, and then you got the ones with just the printed. Got the Z80, which I think, yeah, it's a Soviet Z80, codename T34. We've got a dead cockroach design here as well. Interesting. And this is the clock section up here that I've been obsessed with on the other machine. So there are a few places where you've got to be careful. The especially here, I guess. Just got to make sure that you're not shorting. For example, maybe that one. Maybe that one. That's this is no. What that's I was going to say that's the RAM KR565, but it's not. That one. Depends if the pin is active or not. I don't know. If the pin's not used, then it doesn't matter, obviously. But yeah, I might check those ones. Yeah, so there we go. Oh yeah, just a single 16K EEPROM and an expansion port. I don't know why didn't they just copy the Spectrum expansion port? Anyway, okay, let's power this up, and I might just fix a few of those first as well. Okay, I think they pretty much all look okay now. I'm pretty sure this is working because it was making the tick 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 sound, but I just couldn't get any video output from it. So one thing is we could try the baseband as well, get composite CCAM out of it, I guess. So that's what that looks like in there, if you'd be interested. So I could, whichever one is not ground. So I do actually have a little quick little thing I use. This one here. So I can just hook it up to get a composite, just check for composite. So I might do that once I get the power supply, and then we'll look at the RGB output. All right, I can prove that it works. Well, one way I do it. So look at this. This is a pretty neat connector. So it is keyed. There's a horizontal piece on one end, and it's got a rail on either side, so it just slots right in, like so. How easy is that? Too easy. Right, so keyboard's on. So 7-pin everywhere. I mentioned that, didn't I? There's my power cable. There we go. Seven-pin DIN for just 5 volts and ground. Okay, plug that in. It's now powered on. And you get the little key press sounds. If I can get the microphone to hear it. Bring it down here. So it's definitely running. It's just no video. Well, when I tried it last, there was no video, so I may have had the wrong pinout. So I'm looking at the, I'll just unpower. I'm looking at the UHF modulator. So it does have a thing that goes on the bottom as well. So I've taken that off. So it does have, I was a bit worried that there was the signal going in, the signal and 5 volts going in, but they do actually have a little bit of kind of insulation tape covering the trace, and also there's a couple of signals in there as well that go in. So it should all be okay. But when I was testing the continuity between the ground and the signal, it was like 0.1 ohms, so yeah. Anyway, let's try and find my, well, let's have a look on here. Which one is it? I think it must be the bottom. There we go. So VTC, is it? I think that, oh, I remember having this discussion. Something like that. Magnetophone and whatever that was. I wasn't sure which one the video output was. I might have a poke around the schematic and check some signals. And I'll be back. Alright, so if we assume that this is the RGB out, I just noticed some suspiciously missing components. They've been chopped off the board unceremoniously. For a few rubles perhaps, I'm not sure. Can you zoom in more? Or maybe that's as good as you need to get. Yeah, so maybe that could be why we're not getting any video signal perhaps. I'm just looking at the schematic. Don't mind looking on the screen. So we've got BGRI intensity, I guess, going through DD44. Now you could ask, what is DD44? Well, it's just AND gates. Well, just a buffer really, I guess, is it? Or is it an inverter? NAND, I guess they're NAND gates, I guess. DD44 is a KR1533 LA9, so whatever that is. But I guess, guessing by the symbol, it's NAND, the NAND gate. So we're just inverting the signal there. Going through there, VT13. Actually, where is the, down here, isn't it, the connector? There. Along there. Okay, that's where that's, okay, they tapped off there. Yeah. So I'll just try and figure that out still. But I'm a bit concerned by these, especially when there's a group of 3 transistors. It could be why they're missing. VT13, VT14, KT361, perhaps. Oops, perhaps that could be the issue right there. God damn it. Let's see if the baseband, if I can get baseband out of it somewhere. I think I found these NAND gates, DD44 and DD45. That's these two here. So the problem is none of these components are numbered or labelled on the board. So even if I could replace these, I have no idea what they were because they're not labelled. So I'm going to have to try and figure it out. So I don't know. So which one of these is DD44? Which one's DD45? So DD44 handles RGB and DD45 handles intensity. So I'll try and figure that out. And then maybe we can figure out, so then after the NAND gate, well after the NAND gate actually we go out to the, yeah, we've got some resistors, but otherwise we go straight out to the connector. Alright, so maybe that's enough there just to figure out those. All right, let's see. Okay, figured it out. Where's my pointer? So this is D44. That's D45, I assume, because pin 3, 8 and 11 are directly connected through to the DIN here, which is what we have here. 3, 8 and 11 coming straight out to the DIN there. So we should have RGB signals on there. On this one here, let's have a look. Right, okay, powered on and running. So the first one will be pin 3, which is blue. Could it be one of these things where it's inverted? And you've got to run it through inverters to get the right signal out or something. Okay, that's like on the Lvov, isn't it? Alright, so that's blue. That looks pretty good, doesn't it? That's 1 volt peak to peak. Oh, sorry, that's 2 volts per division there. That looks pretty good. It's kind of what we'd expect, isn't it? Look how square they are. Wow. Okay, that's pin 3. So that's the blue signal. Yep, pin 8, which will be the green signal. Pins 1, 2, 3, 4, 5, 6, 7. So pin 8. Hang on. I've got a good connection here. It doesn't look as good, does it? Come on. Well, it's got a lot of DC, or a little bit of DC on it, doesn't it? Why is it up so high? That's a bit different to the blue signal, isn't it? Should it be like that? Okay, that's pin 8. 1, 2, 3, 4, 5, 6, 7. Okay, pin 8, pin 11, which should be red. 8, 9, 10, 11. Grab, stick it on there. Okay. It's a bit different. So does that green signal, does that mean it's got what am I looking for, this one here? Does that mean it's got a DC in it? Is that a bit of noise? Should that be there on the... interesting. Okay. Now intensity, don't worry about intensity. Where does sync come from? Sync, okay. Sync comes from all those missing transistors. All right, okay. That's probably why it wasn't working. Let's have another look. Okay, so that's our NAND gates, so basically inverters. And so RGB signal, which comes through here, connector, and I think that's where the sync, well, we've got horizontal, vertical sync up here, but if we look at, so this is our RGB here, then we go here, all of this stuff, to get our sync signal. So we've got 3 transistors there, which I suspect maybe, I don't know. Oh no, okay, no, maybe we've got them. 1, 2, 3. Maybe we've got them. The problem is you can't, they might be okay, but it's still, we're missing I'm going to have to trace it out again. Alright. But I'm just very suspicious. Missing components kind of between our signal and our connector. I think I'm always done. Yeah. So looking at the connector again, 7-pin, there is actually a plain video, pin 7. So if we look at that, comes through here, through those two transistors, and so yeah, so I think I've found it, which is that there, right there, and that's what we get. But I don't know if you can see it, there is text there. So the video output's working, but it might be inverted. So that's composite. So it might be inverted, perhaps. Maybe I need to stick these through an inverter again, or maybe I need to just pick it off here, rather than sticking it through an inverter and another inverter. Maybe take the signal there. But yeah, but which one? The green signal was a bit weird anyway, wasn't it? I think it had a bit of DC in it, perhaps. Yes, so we're making progress. So the video is working. It's just not correct. So the machine is working, it's just not correct. So rather than pins 1, 2, 9, 10, 12 and 13 are the inputs, BGR. Maybe I need to pick those up. Let's see. All right, I might call it a night, but I've traced the inputs down to this chip here, whatever that is. We're going to see. It's something M8, TM8, KR1533TM8, I reckon. So the RGB comes out of here, gets inverted there. Some weird shit went on here, and then we've got output there. So I'm not sure what that one is, but on the I'll have a quick look. Let's have a quick look. Sorry. So what was it? TM8. KR153 TM8. So DD51 to 54. Ah, this is where maybe I saw it. Here we go. Yep. So we've got these separate ones here. DD51. I should really do a screenshot of this, shouldn't I? And then we've got 51, 52. So we've got several copies of the signal. B2, R2, G2, I2, B3, R3, G3, I3. So I don't know. And DD54. So I'm not sure what the different... Alright, so B1 goes into here to get B2. B2 goes in here to get B3. B3 goes into here to get B. Okay. Alright. So no, I doubt someone... Oh, that's the equivalent Western part. 74LS175. So it's a... What, 4 input, we've got a clear and reset, so some sort of flip-flop or something, is it? I don't know. Alright, there we go. So, yeah, do I need to invert the signals? Because I know the Ukrainians have done some weird shit like that on other computers where the RGB is inverted, so you need to invert it to get the output. Or is it that one of the signals is just a bit off because of the DC? Let's see. Yeah. There we go. I'll try and fix that key switch tomorrow. Bye for now.